today I'm going to open our discussion on neural networks. So where I will start discussing building nonlinear model, and I will move on to one of the basic structure of a neural network, that is a feed-forward neural network. And I will move on to one good adaptation of a neural network to certain type of data. So for image data, we use convolutional neural network or CNN. So let's go back to day one. So we started talking about general AI and beginning of machine learning. So we went back to 1950. So there was a famous Dartmouth conference, and lots of discussion has been studied from there. In the meantime, we also discussed some of the switching function or some aggregation function. So here you have set of inputs, and based on those inputs, you're going to aggregate them using weights. And after that, we went through some activation function. Alright, so we already have discussed this kind of structure using logistic regression. So you have input, and they were aggregated with input weights. At the end of the day, you're going to put them in an activation function, and that will get you the output or prediction. And this idea actually studied from some biological unit that is called as a synapse. So well, if we look at our brain, there are some kind of a connection between cells and our body structure. So there are some structure called as a synapse, and these make some signal within our brain or other components of our body. And each of these synapses are connected through the structure like this. So on one side, you have similar structure like this. So where it says there are nucleus and some dendrites and cell body and axon, where similar structure are placed here, placed here, placed here, placed like this. And that is again interconnected with other similar structure like this. So when we build and discuss logistic regression, we were looking at one single unit of this structure. Well, actually, logistic regression was not directly oriented by this kind of biological components, but we can put some analogy. They are similar, and they are sharing lots of similar components. But a neural network is based on the observation from our brain. So our brain has a certain connectivity between those biological components. Okay, so each of these components are cascaded along with multiple layers, and each of these units are connected again and again and again like this. So the observation of our brain basically resulted in some mathematical function that is called as artificial neural network. And that has been dated back to 1943, so it has been a really long time ago. So this is the actual beginning of a neural network. So using this kind of a network, people try to learn some decision-making process. So like what we have done so far, where you have set up an input and you have an output. And our goal is to learn a function, fx, that results in the output value as close as possible to the ground truth. And the structure of this function is based on the structure of the brain. So the idea is starting from these two guys. And people thought this could be one possibility to build a machine learning or a statistical model to make a decision. But like we have discussed, this hasn't been very long, because Minsky and Peppert, they pointed out the neural network has an innate problem. So actually the initial unit, this individual unit, where we studied this as a logistic regression, but it has original name as perceptron. So this single perceptron can do some decision making, but cannot even do really complex problem like this XOR problem. So a perceptron is like logistic regression. So it can draw some straight line to make a decision, like this or like this. But however you draw such a line, you cannot completely distinguish red and blue dots. Well, in order to completely separate red and blue dot, you need to have some line like this. But this is something perceptron cannot do. So Minsky and Peppert, in this way, they sort of tackled the limitation of perceptron, and somehow this goes to the population or all the crowds that neural network has no future at all. And that gave us the first AI winter. So all the government funding has been sort of stopped, and many of the research has been stopped as well. But still, people did not give up, and they tried to find how to model nonlinearity using the perceptron model. So one way to deal with the nonlinearity that we have discussed is using the feature function. So using feature function pi instead of a simple input, you could model the nonlinearity. So combination of x1 and x2, combination of x squared and x cubed, something like that. You can try to depict a complicated space defined by your original input. Well, we have studied similar practice using logistic regression. So here is the feature function, and you put the aggregation of weighted sum into the sigmoid function. But this has some issues, so how to find a right feature function where there is no clue, so you need to do lots of trial and errors. And also using feature function does its job, but at the same time you are increasing the computational demand to a great extent. So this is something we don't want to have. There are a second option that is using the kernel function. So by putting the kernel function inside of a method like support vector machine, you could effectively model the decision boundary that is defined by the nonlinear combination of your input. And compared to the first method that we discussed, so compared to the feature function, you can find the nonlinear decision boundary with less amount of computation. So SVM has been loved by many researchers, but at the same time, it cannot address this question. So how to choose a right kernel? Well, there is no clue, so you still need lots of trial and errors. And this is something taken by the neural network people. So instead of having a single perceptron, well, maybe we can add multiple layers of those perceptrons to get the same output. So perceptron itself is simple, so it is easy to handle, easy to deal with. And instead of having a single unit of perceptron to make a decision, well, let's cascade them in multiple layers. And in between them, we want to add some nonlinear mapping function. So in between layers, nonlinear mapping, nonlinear mapping. Like this. And they formed a model named multi-layer perceptron. So compared to this, logistic regression can be understood as single-layer perceptron. So multi-layer perceptron, MLP in short, it also has another name, feed-forward neural network, or FFN, or FFNN. So here is the example. So you have the input variable, and they are aggregated using some weighted sum. And each of those weighted sum goes into an activation function. And then the output of activation functions, they are again aggregated using a weight vector and activation from the second layer that goes into the final decision. So this kind of MLP, or multi-layer perceptron, we have, where we can see the input and we can also see the output. But we cannot see something in the middle. So something in the middle that cannot be observed, this is a hidden layer. So this model is called as MLP with one hidden layer. So let's go back to our discussion from the logistic regression. So it is aiming to estimate the probability using a sigmoid function. So we can see this is the aggregation, and the outcome of the aggregation goes into a function, logistic function. This was an activation function. and this is the final outcome. Well, compared to this, the original perceptron structure was like this. So again, weight vector and summation or aggregation, and here is the activation. So this is a simple switching function. So when something is smaller than certain value, in this case, the threshold is set as 0. When something is smaller than the threshold that is 0, something is larger than the threshold that is 1. So this simple unit vector was introduced using the original perceptron. But unit function has a limitation. Well, this unit function is not differentiable at the threshold. So in order to avoid this difficulty, a different set of activation function has been introduced and used. So sigmoid, like we have seen, and also hyperbolic tangent or tan-h in many articles, that is looking similar to the sigmoid function, but the outcome range is different. So ranging between 1 and -1. And these days, rectified linear unit or ReLU function is used more frequently, more widely. And some adjustment after ReLU, for example, leaky ReLU or exponential LU, where these kind of variants also being used. So, well, let's quickly recall. So we are cascading multiple linear units to form a nonlinear decision making. So this is a simple linear unit, and you are cascading them into multiple layers. So it can be 2-layer, or MLP with 1 hidden layer, or MLP with 2 hidden layers. So while you are doing this, one important thing is at the end of each layer, you have to have an activation function. Where if you don't have activation function, where even if you have 100 different layers, where it cannot be nonlinear decision making at all. So we are going to see why it is in the later slides. Well, anyhow, that is a sort of brief and mild introduction to neural network. So, well, you will get the idea what is the difference between a simple perceptron or simple logistic regression and the neural network that we are going to discuss.